How's it going? Today on Milanese Math, we're going to learn how to find x and y intercepts. Okay, so what exactly is an x and a y-intercept? Well, let's take a look at our graph here like on number 1. The directions say find the x and y-intercepts. All that really means is that they're just looking for an ordered pair where this little blue line that's drawn here, where does it cross the x-axis? That'll be the x-intercept. And where does it cross the y-axis? That'll be the y-intercept. So for instance, in this problem, it's pretty straightforward. You can see that the blue line intercepts our x-axis right here. That's where the blue line and the horizontal x-axis meet each other. The coordinate for that point, or the x-intercept, is 15, 0. So most of the time it's not enough just to circle it. They want you to write it down as an ordered pair. So that's our x-intercept. Our y-intercept is the same thing, but on the y-axis. Where does the blue line intercept the y-axis? And it looks like it's right here. So let's go ahead and write that down as an ordered pair. That would be 0, -3. Okay, so it's pretty straightforward. If we have a graph and they ask for the x and the y-intercepts, just look at it and write down the coordinates. So if you're watching this tutorial, what I would do now is pause the video and see if you can do number 2 on your own. Go ahead and pause the video now. Hopefully you've had a chance to pause it and try it. Let's go over it and see if you got it right. So if they're asking for the x-intercept, it's where does this blue line cross the x-axis? It's right here. And the coordinate is -4, 0. The ordered pair that describes that position is -4, 0. Similarly, the y-intercept is the place where it crosses the y-axis. It's right here. And that ordered pair would be 0, -2. So finding the x and y intercepts are really easy if you're looking at a graph. Before we move on though, I want to point out one thing that's sort of important. Check this out. Go back to the first example and let's look at that one. Did you notice that when we were trying to find the x-intercept, that the y part of that answer was 0? Similarly, when we were looking for the y-intercept, the x part of the answer is 0. That is not a coincidence. Think about what it means to be on the x-axis. It means that you don't have any height. You don't go up or down at all. So the height is always 0, or the y value is always 0. That means that no matter where the x-intercept is, it'll be some number, 0. The same thing with the y-intercept, except that now when you're looking for the y-intercept, the left to right value of it is 0. So y-intercepts are always 0, some number. And you can see that that's true over here on number 2 as well. When we were looking for the x-intercept, the y part of the answer was 0. And when we were looking for the y-intercept, the x part of the answer was 0. That's going to be really important here in a second. So let's hop down to numbers 3 and 4, and the directions say use x and y intercepts to graph the equation. So basically what it's saying is find the x and the y intercepts, but they're not going to show you a graph like they did in numbers 1 and 2. So what I like to do when I'm trying to graph an equation is just make a little xy table, and that is going to work here as well. So x and y. Now, here's the thing you can kind of cheat. If you're trying to find the x and the y intercepts, you know something really specific about them, and that is that the x-intercept always has a y part of its answer as 0. In other words, if it's on the x-axis, it doesn't have any height, just like we just said. So that means that when you're trying to figure out what numbers to plug in, I would definitely plug in a 0 for y, because x-intercepts always have a y component as 0. Similarly, I'll let you take a wild guess. When we're trying to solve for the y-intercept, what number do you think we're going to plug in for x? I just said it, 0. So you can plug in a 0 for x and it'll tell you what the y-intercept has to be. So we're going to break this down into like 2 little algebra problems, and then we can figure out what the x and y-intercepts are. All right, so let's try it. So we're working with this equation up here. And the first thing we're going to try to do is figure out what the x-intercept is. We know x-intercepts have a y value of 0, so I'm going to rewrite that equation just like I see it, -2x plus 4 times y, but instead of putting y, I'm going to substitute in a 0, because x-intercepts have a y value of 0. Okay, so when you're so if that's confusing, just remember, when you're solving for x-intercept, make y be 0. All right, so let's finish this equals 8. Now, if we can just solve for x, we're going to be good. So negative 2x, 4 times 0 is just 0, so I can go ahead and skip down to equals 8. And then to get x by itself, the inverse of multiply is divide, so we'll divide by negative 2, and that gives me a final answer of x equals negative 4. I'm going to update that in my table. When I plugged in a 0 for y, I got a negative 4 for x. So that's our x-intercept. Let's go ahead and throw it on the graph here. Go ahead and make a dot at negative 4, 0. That would be right there. And let's do the same thing to finish this up and figure out what the y-intercept is. So let me erase this. Now we're going to do the same thing, except this time, instead of plugging in a 0 for y, we're going to plug in a 0 for x. So I'm going to go back up to this equation and just plug in a 0 for x. So I would write this as negative 2 times 0, I'm plugging in a 0 for x, plus 4y equals 8. If this is a little confusing to you, just remember it's kind of like opposites. If you're looking for the x-intercept, make y be 0. If you're looking for the y-intercept, which is what we're doing here, make x be 0 and just solve it. Negative 2 times 0 is 0, so I can drop straight down to 4y equals 8. And then I guess to get y by itself, we would divide by 4. And that leaves me with a final answer, y equals 2. So our y-intercept is going to be 0, 2. So I'm going to drop that on my graph here, 0, 2. So not only did we find the x and y-intercepts, but now we can graph this line. Let me get my ruler out. And so all I got to do is connect the dots. I like to draw the line all the way through both sides of the dots to show that the line goes forever and ever. So something like that. Okay, cool. So when they say to graph the equation using x and y-intercepts, I would just make a little xy table, plug in zeros, and solve for it. So right now, I would, if I were you guys watching the video, I would pause it and try number 4. Okay, now that you've had a chance to try number 4, let's go over it together and see if you got this right. So I'm going to make an xy table, and remember, the numbers that I want to plug in here are just zeros. I'm going to do it once where I make y be 0. That'll tell me what my x-intercept is. And then I'll do the whole problem again, but this time I'll make x be 0, and that'll tell me what my y is. So let's start at the top. Oh, and by the way, we're using this equation, x minus 3y equals 3. I should probably point this out that this is sort of extra information, but when you see equations that look like this, something times x plus or minus something times y equals a number, that's what's called standard form. So you might have the directions, they don't say it here, but they might have directions that say put the equation in standard form and then graph it or do something to it. They just mean get your x's and y's on one side and your constants or your regular numbers on the other. But that's not really relevant right now. So right now, all we're going to do is go plug in zeros. So the first time we do this, we're going to make y be 0, and that'll tell me what my x-intercept is. So x minus 3 times 0 equals 3. 3 times 0 is 0, so actually we can hop straight down to x equals 3. That means that when I plugged in a 0 for y, I got a 3 for x, and that means that the x-intercept is right here at 3, 0. So go ahead and put that on your graph while you're thinking of it. All right, let's just do this again, but this time we're going to plug in a 0 for x and see what we get. So instead of x minus 3y, it's going to be 0 minus 3y equals 3. And since 0 doesn't have an effect here, we can just drop down negative 3y equals 3. And then I'm going to divide by my coefficient, which is a negative 3. And that gives me y equals 3 divided by negative 3 is negative 1. So that if I update my table, when I plugged in a 0 for x, I got a negative 1 out for y. And so let's just graph that point. So 0, negative 1 is right here. So we've shown where those x and y intercepts are. So to draw the line, it's literally just connecting the dots. Again, I like to draw my line going all the way through both dots so that I can show what's going on here. Because really this line goes forever in both directions. Cool. So hopefully that shows you guys a little bit about how to use x and y intercepts.